Okay, so good morning, class. So we will be discussing Module 10, or we have the Convergence and Divergence Test. Okay, so how are we going to find out if the series is converging or if the series is diverging? Okay, so ito yung mga test to find out the ano natin yung mga series natin. Okay, so a sequence is nothing more than a list of numbers written in a specific order. So the list may or may not have an infinite number of terms. So although we will be dealing exclusively with infinite series, or generally sequence terms are denoted as follows. So A1 is the first term. Okay, A sub 2 is the second term. Hanggang sa A sub n, yun yung n term, and A sub n plus 1, okay, will be the n plus 1 term. Okay? Sige. So for a convergence and divergence test, so the question is if the limit is limit of a sub n approaching to n raised to approaching n to infinity, so exists and is finite, we say that the sequence is convergent. Okay, so ito yung uh, test mo. If your limit of a sub n from n to infinity, from n to approaching to infinity, then uh, the uh, the the series is the sequence is convergent. Okay, so however, if the limit of a sub n from n approaching to infinity does not exist or is infinite, we say that the sequence is diverges. Okay, so note that sometimes we will say the sequence diverges to infinity, or if the limit of a sub n from n to infinity is equals to infinity, and if limit of a sub n from n to infinity is equals to negative infinity. So we will sometimes say that the sequence diverges to negative infinity. Okay? So minsan sasabihin natin yung diverges is approaching to infinity if ito yung condition. Okay, if ganito yung condition, ang sequence natin is diverges to negative infinity. Okay, so for example, you have a series of n plus 1 over n squared. Okay, yung whereas yung n mo is from 1 to infinity. Okay, so writing it down from n equals 1, so 1 plus 1 equals 2 over 1 squared, therefore that is 2. Next one is 2 plus 1, which is 3. 2 squared is 4, 3/4. Next is 4/9. Next is 5 over 16. Next is 6 over 25. Okay, from n equals 1, 2, 3, 4, 5, so on and so forth. Okay, so taking the limit of this series, if a sub n from n to infinity. Okay, so of n approaching to infinity. So the question is it converging or is it diverging? Okay, so here are the tests. Okay, so number one is the divergence test. So in this test, you will find out if the series or the sequence is diverging. Okay, so in the divergence test, it is used to determine whether the series diverges based on the series and behavior. Okay, based on the series and behavior. Okay, titingnan lang natin yung end behavior ng series. So for it cannot be used alone to determine whether the sum of the series converges. So it is only applicable for divergence test. Okay, for diverging series lang. So let's say if the limit of your a sub n when n is approaching to infinity is not equals to 0, then the summation of your a sub n will be diverged. So take note that if the limit of a sub n from n to infinity is 0, then the series may diverge or may converge. Okay, so ibig sabihin, dalawa pa pala to. Kapag yung limit mo is 0 equals to 0, dalawa yung possible answer. It may converge or it may diverge. Okay, so kapag ganito yung condition mo, not equals to 0, automatically the summation of your a sub n will diverge. So let's try for an example. Okay, so for a sample problem number 1, so determine if the following series is convergent or divergent. Okay, so the question is, ito try na natin to using a divergent test if this series is diverging. Okay, so paano ba 'yon? So 'di ba ang tawag dito, ang condition to diverging is this one. If the limit of your a sub n approaching to n infinity is equals to 0. Okay, so we will try if the limit of my a sub n from n approaching to infinity is not equals to 0. Okay? So, ganyan yung gagawin ko. So, paano ba using your limit? Okay, naalala nyo ba kung paano take ng limit of a function? So, your calculus. So, ganito yon. Take your limit, then n approaching to infinity, then write the function. So, the function, the series is n over n plus 1. Okay? To simplify this, n over n plus 1, para para ma-substitute natin yung infinity dito. Kasi kapag sinubstitute natin siya right away, so infinity over infinity plus 1. So mangyayari dyan, infinity over infinity. Okay, so wala kang makaka-come up na solution. So the solution will be take the higher order of the function. Take the highest order of the series. Highest order of the series. So, then divide all terms. Then divide all terms. Then divide all terms. Okay. So in this series, you have n over, sorry, this one should be 2n plus 1. N over 2n plus 1. So ano ba yung highest order ng series? So yung order ng n is 1, ang order ng 2n is 1 pa din. So therefore, the highest order of the sequence or of the series is 1. So therefore, we will divide all terms by 1 over n. Okay? We will divide all terms by 1 over n. Kasi yung ano natin, ang highest order natin is n raised to 1. So, di-divide natin siya ng 1 over n raised to 1. Lahat yan ipapandivide natin to. Okay? So, ganito yung gagawin natin. So, you will divide n by 1 over n. So, n over 1, n divide n, yan, n divide n. So, kaya yan, may ganyan. So, 1 over n din to. Okay, so, mas maganda pag mas makikita nyo ganito na lang yung pagsulat. Okay, limit of n approaching to infinity. Then, yung n mo, divide mo by order n. Yung 2n mo, divide mo ng order n. Plus yung 1 mo, divide mo ng order n. Okay? So, therefore, this one will be n over n is 1. 2n over n is 2. And 1 over n is 1 over n. Okay? So, ganyan, kaya ganyan yung nakuha. So in this form, you can substitute right away na yung yung n equals to infinity. Okay? So kapag sinubstitute mo yung n equals to infinity, so 1 over infinity will be 0, di ba? 1 over a very large number is approaching to 0. Therefore, 1 over 2 plus 0 is equals to 1/2. Okay, since 1/2 is the limit that is not equals to 0, therefore, the limits of the series term isn't 0, and so by the divergence test, the series diverges. Okay? So therefore, the series diverges. Okay? So ganun lang. So the solution will be take the highest order of the series, then divide that that term to all the terms of your series. Okay? So yan. So do you have a question for sample problem number 1? Okay? So kapag n squared to, may isang n squared. So i-divide mo lahat ng terms by n squared. Kung may n squared dito or may n cube, siya yung highest. Okay, ganun. So sample problem 2, so this one. So determine if the following series is convergent or divergent using a divergence test. Okay, using divergent test. So we have the series 4n squared minus n cubed over 10 plus 2n cubed. Okay? So, kung mapapansin natin, if we substitute right away the infinity, mangyayari infinity over infinity yan. So, we can simplify that by dividing all terms by the highest order of the series. Okay? Ano ba yung highest order dito? So, n squared to, n cubed to, n cubed to. Therefore, the highest order is n cubed. So, we will divide all terms by n cubed. So, 4n squared over n cubed. Bakit ganyan yung sulat sa pen? Okay. Minus n cubed over n cubed. Sorry. All over 10 over n cubed plus 2n cubed over n cubed. Okay. So, what you have left is this one. 4n squared over n cubed, that is 4 over n. Okay, n cubed over n cubed, that is 1. Okay, 10 over n cubed as is 10 over n cubed. And this one, 2n cubed over n cubed, that is 2. Okay, so at this form, we can substitute right away the infinity or n equals to infinity. So if we substitute n equals to infinity, okay, 4 over infinity, that is approaching to 0. 10 over n cubed, which is 10 over infinity, is also approaching to 0. Okay, so therefore, what you have left is negative 1 over positive 2. Therefore, that is negative 1/2. So by the condition of the divergence test, if the limit, since the limit of the series is not equals to 0, therefore, the series is diverges. Okay, so diverges to. Okay, so okay lang ba? May question ba kayo dito sa divergence test?
None po.
Okay, so madali lang naman siya. So next is by using a telescoping test. Okay, so next is using telescoping test. So yung telescoping is this is a type of infinite series that utilizes the technique of partial fractions. So which is a way for us to express a rational function or algebraic function as a sum of a simpler fractions. So we have three steps. Okay, for step 1 is find a general formula for S sub n or the summation of the series. Okay, and step 2, after that, take the limit of that S sub n as n approaches to infinity. If the limit of your S sub n from n approaching to infinity is equivalent to a finite number, then the series will converge. However, if the series of S sub n limit approaching to n equals to infinity is equivalent to infinity, so equivalent to infinity, the series will diverge. Okay, so ayan. So if yung limit of your S sub n or yung summation series mo is from n to approaching to infinity is a finite number or any number. Ibig sabihin ng finite number is any number, hindi siya infinite. Okay, so that is converging. However, if the limit of your summation of the series or S sub n as n approaching to infinity is equivalent to infinity, then the series will diverge. Okay, so sample problem number 1. So using a telescoping test, determine if the following series is converging or diverging, or convergent or divergent. Okay, so let's say we have an example na series na summation of n equals to 1 approaching to infinity, n equals to 1 to infinity of 1 over n minus 1 over n plus 1. Okay? So the solution, sabi niya dito, step 1 is find the general formula of the summation of the series. So kapag may nakita kayong gantong itsura, okay, sabi niya, in order for us to tell if that we will be using telescoping test, if the technique of partial fractions is much simpler to express the rational function. Okay? Since naka-fraction siya in two terms, okay, ganito, so it is much better if we use telescoping test. Okay, so paano ba to? So gagawin natin, substitute lang natin yung parang ang mangyayari, we think outside the box. Parang titingnan natin yung buong overview ng buong series. Titingnan natin yung overview ng buong series. So let's say n equals to 1. So since sabi niyo dito, starting from n equals to 1, so substitute natin yung n equals to 1. So 1 over 1 minus 1 over 1 plus 1, that is 1 over 1 minus 1 half. This is n equals to 1. Okay. When n equals to 2, 1 over n, so 1 half minus 1 over 2 plus 1, that is 1/3. So this is n equals to 2. This is n equals to 3. Okay. So kung mapapansin natin, yung n equals to 1, 2, 3 lang, okay, tatlo lang yung terms, mapapansin natin lahat ng middle terms is nagka-cancel out. Kapag if we take the sum, okay, tingnan mo. Negative 1 half, may positive 1 half dito. So magka-cancel yan pag pinag-add mo. Negative 1/3, okay, negative 1/3, may positive 1/3 dito, magka-cancel yan if pinag-add mo. Okay, so if you try n equals to 4 then, so that is 1/4, okay, minus 1 over 4 plus 1, that is 1/5. Okay, so mapapansin mo, yung 1/4, negative 1/4 plus positive 1/4 magka-cancel din. So what can you say? Lahat ng middle terms is magka-cancel out. Yan, this one, this one, this one, this one. Ang tanging matitira lang is yung first and the last term. Okay? So kunwari, n equals to 4 ha. Ang natira na lang dito is yung first and yung last. 1 minus 1/5. Okay, kunwari n equals to 2. Ang matitira dito is yung first and yung last. N equals to 3 hanggang n equals to 3 lang. Ang matitira dito is yung 1 and 1/4 o yung first and the last. So therefore, okay, therefore, we can generalize the formula for the summation of the series as 1 minus 1 over n plus 1. Okay, so ganito lang. 1 over 1 minus n plus 1. Okay, so bakit nangyari to? 1 over 1 minus n plus 1. Yung first term kasi is always 1. Okay, yung first term is always 1. Okay, then yung last term is always 1 over n plus 1. Okay, so that is the the general formula for the summation of the series. Okay, so as you now have your formula for the summation of the series. So take the limit of that summation of s sub n as n approaching to infinity. So we will take the summation of this s sub n as n approaching to infinity. So 1 minus 1 over n plus 1. Okay? So pwede na natin i-substitute right away yung dito yung n, value of n. Kasi wala tayong masosolve na infinity over infinity. Okay? So this one, substitute mo lang yung infinity. So 1 over infinity plus 1, that is infinity. So 1 over a very large number is approaching to 0. So therefore, this will be 0. And what you have left is positive 1. Okay? So therefore, so sabi dito sa condition, if your limit of the summation is any finite number, therefore that is converging. So if the limit of s just sub n is equivalent to infinity, that is diverging. So therefore, since the limit of n equals to n approaching to infinity is a finite number 1, therefore the series is converging. Okay, so any number, kapag any number to, that is a finite number, so that is converging. Okay, so do you have questions for telescoping test for this sample problem? Is that clear ba? Clear ba?
Yes po.
Okay. So next, sample problem. So using your telescoping test, determine if the following series is converging or diverging. Okay. So let's say we have your series 1 over 2n minus 1 multiplied by 2n plus 1 from n equals to 1 approaching to infinity. Okay. So the solution, sabi niya dito kasi hindi na tayo nag-partial fraction since yung buong term is naka simple algebraic fractions na. However, if nakaganto siya, So one fraction term. Okay, so you will take the partial fraction of the series para nagkahiwa-hiwalay siya. Okay. So taking the partial fractions, okay? So 1 over 2n minus 1, that is a over 2n minus 1, okay, plus b over 2n plus 1. Okay, so substitute mo to solve for a, substitute a value of n that will take the denominator be 0 para maging all terms lahat nun is 0. Okay, so that is substitute a is equals to 1/2. That is ito. If a is equals to 1/2, substitute mo dito yung a equals to 1/2. So 1 over 2 times 1/2 plus 1. Okay, so pag sinubstitute mo yon, you have your a. Solve ko na nga lang. Okay. So 1 over, so di ba to solve for a, that is to solve for a, so 2n minus 1 is equals to 0. Therefore, n is equals to 1/2. Okay, so n equals to 1/2. Then, substitute natin yung 1/2 dito sa buong series. So, 1 over, okay. So, 1 over, so makakancel yung 2n minus 1. Ang gagamitin natin is 2n plus 1. That is 2 times 1/2 plus 1. Okay, so 2 times 1/2 is 1 plus 1, that is 2. So therefore that is 1/2. So that is or a. A is equals to 1/2. Okay, then substitute natin yung to solve for b. So n is equals to negative 1/2 naman. Substitute mo siya dito. 1 over 2 times negative 1/2 minus 1. Ang makukuha mo pa ring answer is negative 1/2. Okay? So therefore, the value of a is 1/2, the value of b is negative 1/2. Then substitute mo siya ulit dito sa partial fractions mo. You now have 1 over 4n minus 2. Okay, that positive sign will be negative sign. Okay, and 1 over 4n plus 2. Okay, so ito yung partial fractions natin. So taking these partial fractions, okay, substitute natin siya dito. This will be our new series. Ito na yung magiging series natin. Okay, this one will be our new sequence. Hindi naman siya new modified na lang. Simplified. So this will be our new simplified sequence. Okay, so using a telescoping test, so substitute natin yung n equals to 1, 2, 3 hanggang sa may makita tayong pattern. Okay, substitute natin. Let's say you have n is equals to 1. So 1 over 4 minus 2, that is 1/2. Okay, 1 minus 1 over 4 plus 2, that is 1/6. So this is n equals to 1, 1/2 minus 1/6. Okay, next natin is n equals to 2. So if we substitute n equals to 2, 1 over 4 times 2, that is 8 minus 2, that is 6, that is 1/6. Okay, then this one, 1 over 4n plus 2, that is 8 plus 2, that is 10. So 1/6 minus 1, 10. Then if we substitute n equals to 3, this one, so 1 over 12 minus 2, that is 10. 1 over 12 plus 2, that is 14. Okay, so so on and so forth hanggang 1 over 4n minus 2 minus 1 over 4n plus 2. So if we check again the overview of the summation, okay, mapapansin natin that all terms is magka-cancel out pa rin. And magka-cancel out to, this one. Okay, maybe this one, if we substitute this one, okay, of n equals to 4, magka-cancel out pa rin. So, ang tanging natitira lang is yung first and the last term. Okay, so what is the first? Yung first term is always 1/2. what is the last term is always 1 over 4n plus 2. Diba? Ito yung last term, 1 over 4n plus 2. So therefore, this will be the general formula for the summation. So this will be the general formula for S sub n. Okay, so taking now the limit of the general formula of the summation of the series, okay, as n approaching to infinity. So therefore, that is the limit of n approaching to infinity of 1/2 minus 1 over 4n plus 2. Okay, so mapapansin natin 4 times n, 4 times infinity plus 2, that is infinity. So 1 over any number divided by a very large number is approaching to 0. Okay, so therefore you have 1/2. Okay, positive 1/2. Therefore, since the series is equals to a finite number, okay, sorry, the limit of the summation is equals to the finite number, therefore the series is converging. Okay, so hindi siya nag-infinite. Okay, hindi nag-infinite, equals to a finite number, therefore the series will be converging. Okay, so that is a sample, our sample problem number 2. So ang trick lang dito is to solve for the general formula for the arithmetic, the summation of the the summation of the series. So you just need to take the general formula for the summation of the series. So before that, you can use as a partial fractions, or maybe right away yung sequence nyo is naka simple algebraic fractions na. Okay? So is that clear, class?
Yes po.
Okay, thank you. So next test is using the ratio test. Okay, so suppose you have a series of summation of a sub n defined as this one. So the limit of a sub n, the absolute value of a sub n plus 1 over your a sub n as n approaching to infinity. Okay? So ito parang ano eh. So let's say if you take a sub 1, so yung a sub n plus 1, that is a sub 2. Okay, so taking the limit of that n approaching to infinity, you have your value L. Okay? So parang kung ano yung kasunod niyang term divided by dun sa last term niya, previous term niya. So kung ano yung term divided by the previous term, so taking the ratio of that, taking the absolute value of the ratio for that, and taking the limit as n approaching to infinity, that is the value of n. Okay? So ganyan yung gagawin natin for the ratio test. So if we examine the value of L, okay, so if your L is less than 1, the series is absolutely convergent. Okay, so if the value of L is greater than 1, therefore the series is divergent. Okay, and if your L, okay, if our L is equals to 1, okay, yung L natin equals to 1, the series may be divergent, conditionally convergent, or absolutely convergent. So meron pa siyang three scenarios, 3 cases. Pwede siyang maging divergent, conditional convergent, or absolutely convergent. So you will add additional tests to find out if that is divergent, conditionally convergent, or absolutely convergent. Okay, so let's take an example. So using the ratio test of the following sequence, okay, so we will determine if the following series is convergent or divergent. So let's say you have your sequence of -10 raised to n over 4 raised to 2n plus 1 multiplied by n plus 1 from n equals to 1 to infinity. So taking summation of from n equals to 1 to infinity. So using the ratio test, sabi sa ratio test, the term divided by the previous term, so taking the limit of that ratio as n approaching to infinity, that is the value of our L. Okay, so if we substitute a sub n, okay, using n, so this will be the term. Negative 10 raised to n over 4 raised to 2n plus 1 n plus 1. So if we substitute a raised to a sub n plus 1, okay, all the value of n will be n plus 1. So therefore, this will be n plus 1. 2 times n plus 1, that is 2 times n plus 1 plus 1. Okay, taking this one and this one will be n plus 1. Okay, so ganun lang. So gagawin mo lang is substitute mo yung value of n to be n plus 1. Okay, value of n equals to n plus 1. Okay, so yun yung gagawin mo. So that's why this one, negative 10 raised to n, that is n plus 1, over 4 times 2 times n. So yung n mo magiging n plus 1 multiplied by n plus 1. So yung n mo magiging n plus 1. Okay? Then simplifying this one, this term, pag simplify natin yung term na to, that is negative 10 raised to n plus 1. This one is 2 times n plus 1, that is 2n plus 2 plus 1, that is 2n plus 3. Okay, n plus 1 plus 1, that is n plus 2. Okay, so this will be our a sub n plus 1 and this will be our a sub n. So taking the ratio of our a sub n plus 1 divided by the a sub n. Okay, so that therefore we have negative 10 over n plus 1 over 4n plus 3 n plus 2, then multiplied by 1 over a sub n. Okay, so a sub n natin is this one, so magre-reciprocal siya, that is 4 raised to 2n plus 1 multiplied by n plus 1 over negative 10 raised to n. Okay? Then, simplifying the terms. Okay, paano ba natin ito i-simplify? Diba, ang value of, recall, a sub n over a sub n minus 1, ang mangyayari dyan is, let's say, b times, okay, sorry, that is a n minus n minus 1. So magsusubtract lang yung exponent sa taas divided by the exponent dun sa minus dun sa exponent sa baba. Okay? So that is why this one, okay, yung negative 10 raised to n plus 1, then negative 10 raised to n. Therefore, n plus 1 minus n matitira is positive 1. So that is negative 10 raised to 1. Okay, this one. Okay, so nag-minus lang yung exponent. Okay, nag-subtract lang yung exponent na to. So, n plus 1 minus n, matitira is 1. So, therefore, that is 10 raised to 1. Okay, so ganun po. Okay, so next natin is this one. Of 2n plus 1 to n plus 3. So, 2n plus 1 minus 2n plus 3. So, matitira, cancel yung 2n. So, 1 minus 3, that is negative 2. So, therefore, that is 4 over negative 2. So, that is equals to 1 over 4 squared. Kaya, nasa ilalim yan. So, that is this one. 1 over 4 squared. Okay, next is the term, this one. N plus 1 over n plus 2. So, copy as is. Hindi mo naman siya masisimplify. So, n plus 1 over n plus 2. Okay? So, next is negative 10 over 4 squared. Since this is a constant, pwede mo siyang ilabas. So, negative 10 over 4 squared. So, 10 over 16. Okay? So, iwan natin yung negative. Tama. So, this should be negative 10 pala. Yan. This should be negative 10. Okay, negative 10. Yan, negative 10. So, that is n plus 1 over n plus 2. So, substitute natin yung n plus 1 over n plus 2. So, infinite over infinite. So, that is approaching to 1, value 1. Okay? So, therefore, negative 10 over 16. So, negative 10 over 16 is less than 1. Okay? Balik tayo dito. Yung negative 10 over 16 natin will be our value L. Yan yung value L natin. So therefore, that is less than 1. Okay? So therefore, the series is converges. Okay? That is absolutely convergent. Okay? Ayan lang. Sorry. So yan lang po ang for the ratio test. You will substitute the value of for n as n plus 1, then take the ratio, then simplify and substitute the limit of n approaching to infinity. Okay? So next sample problem tayo. Let's say we have determine if the following series is convergent or divergent using the ratio test. Okay, so let's say you have your summation of n factorial over 5 raised to n from n equals to 0 to infinity. Okay, so from n equals to 0 to infinity. So let's say you have this limit of n plus 1 over 5 raised to n plus 1. Okay, before we go that, sulat ko na lang dito. So a sub n, alam natin that is in n factorial over 5 raised to n. So taking a sub n plus 1, so substitute mo lang yung value of n as n plus 1. So therefore that will be n plus 1 factorial over 5 raised to n plus 1. Okay? So kaya ganito yan. N plus 1 factorial over 5 raised to n plus 1 divided by a sub n. So magiging 5 raised to n over n factorial. Okay? So simplifying this term. So n over n, n minus n plus 1, that is 5 raised to negative 1. Therefore, that is 5 nasa denominator. Okay, so n plus 1 factorial over n factorial. Okay, so n plus 1 factorial over n factorial. So how are we going to simplify factorial and this one? Paano ba natin sila masisimplify? Okay, so as you all know, class, diba, taking 6 factorial, let's say that is 6 times 5 times 4 times 3 times 2 times 1. Okay, and also we can say that 6 factorial is equivalent to 6 times 5 factorial. Tama ba? So since 5 factorial is 5 times 4 times 3 times 2 times 1. So if rewriting this term into for general formula, okay, so this sample problem, this is n plus 1 n plus 1 factorial. Okay, so therefore your n plus 1, which is equivalent to 6, okay, and yung 5 factorial mo, that is equivalent to n plus 1 minus 1. So that is n factorial. Okay, tama ba? N plus 1 multiplied by n factorial. So ginawa ko yon para ma-cancel out yung denominator na to. Okay, so therefore, your n plus 1 factorial will be n plus 1 multiplied by n factorial. So we can now cancel your n factorial. So what you have left is n plus 1 over 5. Sorry. So yung n plus 1 over 5, so taking the limit of your n plus 1 over 5 as n approaching to infinity, so substitute mo infinity dito. So infinity plus 1 over 5, a very large number divided by 5. So what do you think the answer? Approaching pa rin siya sa infinite. Okay, approaching pa rin siya sa infinite. Okay, so a very large number divided by any number, so that is approaching to infinite. So therefore, class, since the limit, since the value of L is greater than 1, the series is divergent. Okay, so therefore the series is diverges. Okay, this one. Okay, so is that clear, class? Okay, so yan, okay na ba? So sample problem again for ratio test. Okay, last sample problem for a ratio test. So determine if the following series is convergent or divergent using the ratio test. Okay, this one. So n squared over 2n minus 1 factorial. So starting, take note, this is starting from n equals to 2 to infinity. Okay? So ganun ulit. This will be our a sub n. So that is equivalent to n squared over 2n minus 1 factorial. Okay? Then taking a sub n plus 1. Okay? Sorry, may this 1. Okay, baba pa natin. Taking a sub n plus 1, that will be yung value of n mo magiging n plus 1 squared divided by 2 times n plus 1 minus 1 factorial. Okay, that will be n plus 1 squared divided by 2n plus 2 minus 1, that is 2n plus 1. Okay, that is 2n plus 1 factorial. So therefore, class, this will be our a sub n plus 1 and this will be our a sub n. So taking the ratio of your a sub n plus 1 and a sub n, you have n plus 1 squared over 2 times n plus 1 minus 1 factorial multiplied by 2n minus 1 factorial over n squared. Okay, so n plus 1 squared, n squared, sorry. So 2n minus 1, 2n plus 1. So yung 2n plus 1, mag-a-approach yan sa 2n minus 1. Pababa mo lang yan. Kasi di ba, you have 2n plus 1 minus 1 magiging factorial is equals to 2n plus 1. Sunod magiging 2n. Sunod magiging 2n minus 1. Sunod magiging 2n minus 2. Magiging that. Okay? Di ba? So that is a factorial, di ba? That is a factorial. Let's say this one. 6 factorial magiging 6 times 5 times 4, pababa. So therefore, hahanapin natin yung merong n factor, may 2n minus 1 factorial. So pangalawang beses na natin itong ginamit ginawa. So as a general rule, if you have a factorial, so sa taas, if you have a factorial term in the numerator, so you and the denominator, so ang gagawin mo, you will simplify or you will factor out that numerator factorial term. Okay? So kaya natin to tinanggal. Tinanggal natin yung numerator factorial term, then this one tinanggal natin yung numerator factorial term. Okay? So kapag take note, kapag may dalawa kang factorial sa taas, you will simplify the numerator factorial term. Okay? So ganon. So that is n plus 1 squared over 2n plus 1, 2n minus 1 factorial. So 2n minus 1 factorial over n squared. So you now have your 2n minus 1 factorial and 2n minus 1 factorial. So you can cancel this out. Okay? So pwede mo na siya lang i-cancel out. Okay, therefore, you have now n plus 1 squared over 2n plus 1 multiplied by 2n multiplied by n squared. Okay? Okay. So the question is it converging or diverging? Okay, you will need to substitute the value, the limit. So L less than 1, L equal, N is greater than 1. Okay, so paano ba to? Bakit nag-come up sa 0? Okay, so taking the limit of this series, that is 0 plus 1, that is infinity over infinity. Okay, this one is infinity. Okay. I think merong error dito. Hindi yata nasulat. Okay. Try ko nga dito. Hiwalay natin. Sige. So that is n squared plus 2n plus 1. Okay. And this one will be 2n cubed. Okay. This one 2n cubed. So 2n raised to 4 2n cubed times 2n plus 1, 2n raised to 4 plus 2n cubed. So ano yung highest term? Highest term is n raised to 4. Okay? The highest term is n raised to 4. So therefore, we will divide all terms by n raised to 4. Tama pala. So n squared over n raised to 4 plus 2n over n raised to 4 plus 1 over n raised to 4 divided by 2n raised to 4 over n raised to 4 plus 2n cubed over n raised to 4. Okay? So what you have left is this one. Balik natin dito. Okay? So that is n squared over n raised to 4. That is 1 over n squared. Tama ba? Okay. Next natin is 2n over n raised to 4. That is 2 over n cubed. Okay. Next natin is 1 over n raised to 4. Yeah, then exactly 1 over n raised to 4 divided by 2. Okay. 2n raised to 4 over n raised to 4 is 2 plus 2n cubed over n raised to 4. That is 2 over n. Okay. So substitute natin yung value of infinity. Okay, so 1 over infinity squared, that is approaching to 0. Ibang kulay. So this is approaching to 0. 2 over infinity, that is also approaching to 0. And 1 over n raised to 4, that is also approaching to 0. And this one is also approaching to 0. Therefore, 0 over 2. Di ba? So 0 over 2, that is 0. Exactly 0. So therefore, your L is equals to 0. That is less than 1. Therefore, the series is converging. Okay. Okay. Sorry. So, ayan. That is the ratio test. So, do you have questions for the ratio test? Mas madali ito, di ba? Compared dun sa, dun sa taking the general term for S sub n. Okay. So for this ratio test, you just need to substitute the value of A sub n and the value of your A sub n plus 1. Then simplifying the answer and taking the limit of n approaching to infinity, then you will compare that value of L to less than to 1. If less than 1, that is converging. If greater than 1, that is diverging. Okay, and if equals to 1, then maybe the series is divergent, conditionally convergent, or absolutely convergent. Okay? Sige. So next natin is using the P series. Okay, so ano ba yung P series na to? Yung P series test is a series of the form, let's say kunwari yung series mo or sequence mo is in the form of this one. Summation of 1 over n raised to P. Okay? So always ganito yung ating form. Ganyan yung itsura ng summation mo or yung series mo. Where your P is any constant power and are called the P series. So if your P is greater than 1, then the series converges. And if your P is greater than 0 but less than 2 or equal to 1, then the series is diverges. Okay? So taking a sample problem. Okay, this one. Sample problem 1, determine if the following series is convergent or divergent. Kapag nakita mo yung gatong form, 1 over n raised to 5 or 1 over n raised to P, di ba? 1 over n raised to P. Okay, this one. So yung P natin, that is equivalent to 5, di ba? P natin is equals to 5. Then if your P is greater than 1, therefore the series is convergence. Therefore the series is convergent. Okay? Ayun lang, ganun lang kadali. Next is sample problem 2. Let's say you have your following series. 1 plus 1 over square root of 2 plus 1 over square root of 3 plus 1 over square root of 4 plus so on and so forth. That is equivalent to 1 over n plus n raised to 1 half. Okay, that is 1 over n raised to 1 half. Kung mapapansin nyo, this one, kung if this is n equals to 1 and this is n equals to 2, n equals to 3, so kung ano yung value of n mo, nagtitake lang siya ng square root. Okay, so parang pwede rin yan, 1 over square root of n. Okay, so that is this one. So para maging come up ka dun sa n raised to p, so yung square root, that is 1/2. So summation of 1 over n raised to 1/2. Therefore, your p, value of p is 0.5. Okay, so therefore, the value of p is 0.5. So that is within 0 to positive 1, 0 to positive 1. Therefore, the series is diverges. So since p is 0.5, therefore that is p is less than 1 but greater than 0. Therefore, the series is divergent. Okay. Next one is the geometric series test. So a geometric series is any series that can be written in the form a sub r raised to n minus 1, or taking a times r raised to n. So geometric series siya. So a sub r raised to n minus 1, or maybe a sub r raised to n. Okay. So taking the value, we can use the value of r in the geometric series test for convergence to determine whether or not the geometric series is converges. So the geometric series test says that if the absolute value of r is less than 1, then the series is converges. And if the absolute value of r is greater than 1, therefore the series is diverges. So kukunin mo lang yung ratio r dun sa geometric series mo. Okay, again, if the value of r is less than 1, therefore that is converges. And if the absolute value of r is greater than or equal to 1, then the series is diverges. Okay, so a sample problem number 1. So determine if the following series is convergent or divergent. Okay, so ang tanging gagawin lang natin is we will simplify the series into the form a sub r raised to n minus 1, or maybe a sub r raised to n. Whereas yung a natin is any value, constant. R natin is a constant then. Okay, so this will be constant. Okay, r natin will be a constant. Okay, so paano ba natin gagawin to? So we will simplify this series into a sub r raised to n minus 1, or a sub r raised to n. Okay, so paano ba natin to gagawin? So we can simplify that. Okay, so pwede mong gawin, ipagsama mo yung mga term para magkaroon ka ng tawag dito. Kasi ang goal natin is mapagsama natin yung dalawa. So, 'di ba, para mapagsama mo lang sila is dapat they have the same exponent. Okay? So, they need to have the same exponent para mapagsama mo sila. Okay, they need to have the same exponent. So, paano ba gagawin yon? So, pwede natin gawin, ilagay natin ito sa denominator. So, simplify lang natin yung negative n plus 2. Okay? Since siya yung may negative eh. Since siya yung may negative, ilagay natin siya sa ilalim. So, 4n plus 1. Okay? Then, yung negative 9 raised to n plus 2. So, So, 9 raised to negative n plus 2. So, pwede mong gawin 9 raised to negative, that is n minus 2. Tama ba? So, negative n, positive 2. So, that is ganyan. So, that is 4 raised to n plus 1 times 9 raised to negative n plus 2. So, an exponent raised to, a number raised to a negative exponent, that will be 1 over that number. So, magiging nasa ilalim siya. Ilalagay mo siya sa ilalim. So, therefore, that is 9 over n minus 2. That is 4 over n plus 1. Okay? So, ganyan yung nangyari, class. Ayan. So, since meron ka ng n plus 1 over 9n minus 2, so pwede mong gawin is kailangan kang mag-come up sa the same exponent para mapagsama mo sila. So, ano ba yung gagawin mo sa n plus 1 and your n minus 2? Okay, ano gagawin mo sa n plus 1 and n minus 2 para mapagsama mo sila? Okay? So, pwede mong gawin, ipaghiwa-hiwalay mo yung mga terms. Okay? Paghiwa-hiwalayin mo yung mga powers. So, paano ba mo gagawin 'yon? Paano po paghihiwa-hiwalayin? So, 'di ba, as you all know, 4 cubed can be written as 4 squared times 4. Tama ba? Okay? So, 4 raised to 4 can be written as 4 squared multiplied by 4 squared. Tama? Okay. So, ganun din yung mangyayari dito. Yung 4 raised to n minus 1, you can simplify that. 4 raised to n plus 1, you can simplify that na yung isang term is katulad ng exponent sa baba. So, yung n plus 1, gagawin nating n minus 1. Pero we need to come up to n plus 1 pa rin. So, ano idadagdag mo? You will add positive 2, di ba? So, n plus 1 para maging n minus 1, that is n plus 1 is equals to n minus 1 plus 2. Okay? So, ulit. Yung n plus 1, you will arrive dapat sa n minus 1 para pareha siya ng exponent sa ilalim. Pero that is not equal, di ba? So, anong gagawin mo para maging equal sila? Mag-a-add ka dito ng positive 2. Okay? So, therefore, your 4 raised to n minus 1, your 4 raised to n plus 1 will be equal to 4 raised to n minus 1 multiplied by 4 squared. Tama ba? 4 raised to n minus 1 divided by 4 squared. Okay? So, they need to have the same exponent and the same base para mapagsama mo sila. And same base. Bakit same exponent to? Same base dapat. Sorry. This should be, they need to have the same base. Bakit exponent yun? Okay. So they need to have the same base para mapag-combine mo sila. Okay, sorry. So next one, this one. So 4 raised to n minus 1 multiplied by 4 squared. Then next is 9 raised to negative n raised to n minus 1. Okay. Multiplied by 9 raised to negative 1. Or same exponent. Bakit ganito? Nakalimutan ko. This should be same exponent. Okay. So they need to have the same base or the same exponent to combine. Okay. Ayan, tama nga. So they need to have the same base or the same exponent to combine. Okay. So next natin is this one. 4n minus 1. Okay, that is 4 squared. Okay, so yung ilalim natin is 9 raised to n minus 2. So 9 raised to n minus 2. So gagawin natin yung 9 raised to n minus 2, gagawin natin siyang ano? The same dito sa n plus n minus 1. So yung n minus 2, what will you do to n minus 2 to be n minus 1? Okay, so ang dadagdagan mo, magdadagdag ka ng negative 1. Okay, so yung n minus 2, you will, this one, n minus 2, this one is n plus 1. So yung n minus 2, you will come up to gagawin mo siyang n minus 1. So magdadagdag ka ng minus 1. So therefore, your 9 raised to n minus 2, okay, your 9 raised to n minus 2 will be equal to next one is 9 raised to n minus 1 multiplied by 9 raised to negative 1. Okay? So that is this one. So 9 raised to n minus 1 multiplied by 9 raised to negative 1. So now you have the same exponent, 4 raised to n minus 1 over 9 raised to n minus 1, this one. Okay? So you can arrive simplify that to 16 times 9. 4 squared, that is 16. 9 raised to negative 1, that is 1 over 9. Okay, so nasa denominator siya. So magiging so 1 over 9, magiging 9 siya dito sa taas. Magiging numerator siya ng 9. Okay? So natira is 4 raised to n minus 1 over 9 raised to n minus 1. So you will arrive to this form. 16 times 9, that is 144. Okay? 4 over 9 raised to n minus 1. Okay? That is S1. So that is 4 over 9. Yung value of, we can say that our A is equals to 144 and the value of R is equals to 4 over 9. Okay? So since your absolute value of R is less than 1, which is equals to 4 over 9, then the geometric series will be converging. Okay? So that is this one, converging. So the question is, bakit tayo nag-arrive sa n raised to n minus 1? Okay? So nag-arrive tayo sa n minus 1 dahil gusto natin siyang ipunta sa ganitong form. A raised to R raised to n minus, A times R raised to n minus 1. So dapat yung exponent niya is n minus 1 if starting siya sa 1. So if starting siya sa 0, ang gagawin mo is ipipilit mo siya as n. Okay? So gagawin mo lang, mangyayari lang doon kapag ganoon, naging raised to n, kung ano yung exponent, equals mo dito yung n, then ano yung idadagdag mo para mag-come up siya doon sa the same results, yun yung gagawin mo dito. Okay, this one. So ganun lang yung trick. Yung trick lang is you will combine the term if they have the same base or they have the same exponent. Okay, so yun yung solution natin. So mas maganda dyan if you can try to practice this one. Okay, so practicein nyo to. Okay, so practicein nyo to using n equal this one, yung a raised to r raised to n. A times r raised to n. So practice nyo to using a times r raised to n. So ang gagawin nyo dito, this one, hiwalayin nyo yung n equals to 1. Okay, so gawin nyo lang tong 0. So example lang nyo lang to nang gawin nyo lang 0. Then you will try to solve for solve nyo na lang yung geometric series if that is converging or diverging if we include 0. Okay, so try to practice this one. Okay, so next sample problem is this one. Let's say a sample problem. Number 2, determine if the following series is convergent or divergent using the geometric series test. Okay, using your geometric series test, ang gagawin natin ulit, since that is equals to n, starting from n equals to 0, therefore, gagawin natin, i-arrive natin siya sa a times r raised to n. So, raised to n lang. Okay, so negative 4 raised to 3n over 5 raised to n minus 1. Okay, so again, para mapagsama ko sila, they need to have the same base or they need to have the same exponent. So magkaiba sila ng base. So what we have to do is dapat parehas na lang sila ng exponent. Okay, anong gagawin ko? Ganito lang ulit. Anong gagawin ko sa 3n para magkaroon ng n? So the same. Magmumultiply ka lang ng 3. Diba? Anong gagawin ko sa n minus 1 para maging n? So, gagawin ko, magma-minus lang ako ng 1. Diba? So, ganun lang din dito. So, yung negative 4 raised to 3n, ang gagawin ko, negative 4 raised to n, magmumultiply ako ng 3. So, therefore, that is exponent 3. Okay? Diba? Ang exponent is, an exponent raised to another exponent, nagmumultiply lang sila. Okay? Then, yung 5 raised to n minus 1, pwede kong gawin, that is 5 raised to n, okay, multiplied by 5 raised to negative 1. Okay? That is 5 raised to n, that multiplied by 5 raised to negative 1. Okay, so ganito yung nangyari. Negative 4 raised to 3. Bakit nasa labas to? Dapat n yung nasa labas. Sorry. 3, then this one, n. Ayan. Ayan. So negative 4 raised to 3 multiplied by n, this one, divided by 5 raised to n multiplied by 5 raised to negative 1. Okay, so pwede mong tanggalin yung 5 raised to negative 1, that is 1/5. So 1 over 1/5 magiging 5. Okay, so negative 64, 4 times negative 4 raised to 3 is negative 64. Okay, negative 64 raised to n over 5 raised to n. So since they have now the same exponent, pwede na natin sila ma-combine. Okay? So pwede mo siyang i-arrange siya n equals to infinity a sub n but a sub n, a raised times r raised to n, this one. So therefore the value of a is 5 and the value of r is negative 64 over 5, taking that absolute value is equals to 64 over 5. Okay, taking the absolute value of r, that is 64 over 5. Since the value of r is greater than 1, 64 over 5 is greater than 1, then the geometric series will diverge. Okay, this one. Therefore, that is diverging. So 64 over 5. So ganun lang. You will simplify your series into geometric series form na a multiplied by r raised to n, starting from n equals to 0 to infinity, or maybe a times r raised to n minus 1, starting from n equals to 1 to infinity. So dalawa lang yung solution. Pwedeng ganito, if starting from 1, or this one starting from 0. Then, taking the absolute value of r, then compare that to value 1. Kapag less than 1, that is converging. Kapag greater than 1, that is diverging. Okay. So, do you have questions for this class? Okay. So, break muna tayo, then discuss na lang natin mamaya yung Taylor series. Okay. So break tayo ng kasi 9 hanggang alas 10 lang tayo, 'di ba? So Wednesday class. Okay lang ba sa inyo magklase tayo ng 10 to 10:30? Or yun na lang yung break natin? Medyo mahaba kasi 9
Yun na lang po siguro yung
break natin. Kasi I think yung Wednesday class, lahat kayo is naka-enroll din sa lab. So wala namang ano dito. So Lec and lab to the same. 9:17, 10:30. Nag-breakfast na ba kayo? Hindi pa? Sige, ganito na lang. Breakfast muna tayo. So mamaya tuloy-tuloy na tayo. So 10:30, we will discuss yung Taylor series. Okay, module 11. Sige. Sige class, thank you. Thank you. Mamaya na lang ulit. Hindi ko na to i-cancel. Ay, medyo matagal. So, sige, i-end ko na lang yung meeting para